In this Fourier series example, which again was from one of our in-class activities, we have a signal x of t, which is written as 5 cosine 300 pi t plus pi over 6, plus 4 sine 500 pi t plus pi over 3. And as I indicated in the notes on this, this does not require any integration at all. It does require Euler's formula though. So writing this using Euler's, we have 5, I'll put the half out front, 5 over 2 times the quantity e to the minus j. This is our theta, so it's 300 pi t plus pi over 6. And it's cosine, so it's plus e to the positive j 300 pi t plus pi over 6, close parentheses. And then we also have plus 4 over 2j, and I'll write it the way we normally do this time, e to the positive j, in this case 500 pi t plus pi over 3, minus e to the minus j 500 pi t plus pi over 3, close parentheses. Alright, so again, I haven't said anything about period or anything yet. All I've done is take the cosine and the sine and write them as complex exponentials using Euler's. Now I'm going to go back and look at this a little more carefully. Alright, so I have 4 terms here. Those are the only non-zero terms that are going to be in my Fourier series representation. I have a 300 pi, actually this is a negative 300 pi, I have a positive 300 pi, a positive 500 pi, and a negative 500 pi. These are all integer multiples of some omega naught. And again, 3 and 5 are relatively prime. The greatest frequency that's common to both, or all 4 of them, is omega naught equal to 100 pi. And then I say, oh, okay, so then this is my third harmonic, excuse me, my negative third harmonic, my third harmonic, my fifth harmonic, and my negative fifth harmonic. Alright, so now I'm going to rewrite this a little bit differently. I said, well, okay, the Fourier series has e to the minus j some omega naught t, jk omega naught t. But what's this going to do? This is a constant. I need to pull this out front. And likewise with this and this and this. So I'm going to rewrite the whole expression. X of t is equal to, and this time I'm not going to do the parentheses, I'm going to have 5 halves times e to the minus j pi over 6 times e to the minus j 300 pi t plus 5 halves e, and notice now this is a minus pi over 6, this is going to be a positive pi over 6, e to the j pi over 6 e to the positive j 300 pi t, and I'll write this one down again below, plus 4 over 2 is just 2, so I have 2 over j e to the j pi over 3 times e to the j 500 pi t minus 2 over j e to the minus j pi over 3 times e to the minus j 500 pi t. Alright, so still not quite done here. I have to identify, okay, first of all, this is going to be my a sub minus 3. This whole thing is my a sub positive 3. This will be my a sub 5. and including the minus sign, that's my a sub minus 5. But this is not exactly the way we want to write things. I have j, and then I have an e to the j. So this is sort of a mix between rectangular and polar. I'm going to rewrite a5 and a minus 5 in polar notation. And if I do that, move this down a little bit more, I end up with, I'll rewrite the whole thing, x of t equals 5 halves, just double check, make sure I get it right, yes, e to the minus j pi over 6 times e to the minus j 3 times, let's make this a little more explicit, 100 pi, again, so this is k, and this is omega naught, t, actually the minus is part of the k, plus 5 halves e to the positive j pi over 6 e to the positive j 3 times 100 pi t. Alright, now j is equal to e to the j pi over 2. So 2 over e to the j pi over 2 is the same as 2 times e to the minus j pi over 2. And I have e to the, that's multiplication, times positive j pi over 3 times e to the j, 5 times 100 pi t. Then, okay, so now I'm going to do the same thing here. This is e to the minus j pi over 2 minus 2 e to the minus j pi over 2 e to the minus j pi over 3. But this negative 1 is e to the j pi. So if I add this pi to pi over negative pi over 2, this becomes a plus. And then I end up with, and that becomes a plus, e to the minus j 5 times 100 pi t. Alright, and then I can combine these, so this becomes 2 e to the negative j pi over 2 plus pi over 3 is e to the negative j pi over 6. And likewise, e to the positive j pi over 2 minus pi over 3 becomes 2 e to the positive j pi over 6. So it's a little confusing that I have the same angle, phase, for both of these terms, although these end up being the opposite sign. Here for the positive k I have a positive pi over 6, and here for the positive k I have a negative pi over 6. And I know some people in class were confused about that, but it just becomes from the combining these two things to get a single angle. And that's it.